Hello, everyone, and welcome to your introduction to NetBrain 10. We're excited to show you all the exciting new features in the latest version of the NetBrain platform. But first, I've got a few housekeeping notes. To reduce the background noise, we have everyone muted. If you'd like to ask a question, the Q&A window is at the bottom of your Zoom screen. You just need to place your mouse cursor over the area, and it should appear. To ask a question, type it in that window. We will try to answer as many questions as possible. And in addition, we will leave some time for Q&A at the end of our session. And now, here's your first presenter, Song Peng, who is NetBrain's head of engineering. Take it away, Song.
Fantastic. Thank you, Chuck. First of all, I just want to say welcome, everyone. My name is Song, and thank you for the warm intro, Chuck. I'm the SVP of engineering here at NetBrain, and I'm joined today by my colleague, Rick Larkin, our director of pre-sales engineering, and who we have the privilege to have the opportunity to introduce to everyone our 4th generation technology, our NetBrain 10.0 release. This is a really exciting day for all of us here at NetBrain. It's been a release that's been about 1.5 years in the works, and we're very excited to show you our monumental release and how it helps us take a huge leap forward in our mission to automate network operations. For this particular release, we really went back to our roots and reminded ourselves really of our mission, and that's to automate every task in network operations. I bring this pie chart from a recent Cisco survey that 2/3 of the network team's time and money is still being spent on keeping the lights on in incident troubleshooting. Because networks are the foundation to everything in your business, each of your tickets, and P1 tickets in particular, are getting more and more expensive. Your entire network is driving the outcomes of the business. With the fragmentation of network environments, more and more vendors and technologies, this has created more complexity, and more specialized teams are forced to be created to operate this vast and diverse network. And with the exponentially increasing tickets and tasks, thousands of tickets a day, this has caused a lot of escalations and handoffs are happening more and more, creating more interfaces and more collaboration that's needed between the teams to be able to operate the network. And then lastly, with all these challenges, 75% of network engineers today still only use CLI. While CLI has been our dependable, flexible, agile tool and the most dependable toolkit in our toolbox, but the scalability has really not advanced the challenges of managing modern networks. So just taking a little bit of a stroll down memory lane, NetBrain really started with the 1st generation of the product in 2007, where it was a rich client with an inbuilt database for personal use only. We used this data to build a solution for the first common denominator for network tasks, and that's map and documentation. The 1st generation technology was also Cisco focused. And for those of you that have been with us since then, back then, you'll have fond memories of our thick client, our rich client, and having all the information within the client itself. In 2012, we took a big leap forward and we introduced this new client server architecture where majority of the network data is now being built in a singular source on a server so that more and more engineers and users are now able to interact in a collaborative fashion. During this version, we also introduced our first QApp technology, the build once, use anywhere automation innovation to simplify automating network tasks. It was also during this time that we introduced the multi-vendor framework to really make ourselves easy to adapt to the vast majority of the enterprises networks that are multi-vendor that is today. And then with the advent of 7.0 in 2017, we took another big leap. And here we migrated fully from the client server architecture into a browser server architecture. This has really allowed us to make NetBrain open to all engineers. So no more installations on your personal PCs. Everything was directly accessible through the browser. This was a monumental advance in our journey and to make really NetBrain available to everyone. During this time, we also introduced runbooks, data views, and all of these things are meant to be able to lower the barrier and simplify everyone's ability to use automation in NetBrain. And during that time, with the advent of API-driven controllers, such as ACI, SD-WAN, NSX, we made a lot of advancements in that area as well. And that brings us to today. We are super excited to unveil our 4th generation product that marks another leap in our mission. So let's get started. Let's take a look what's there. We started 10.0 with a bold goal in mind. NetBrain has thus far focused a lot on making the reactive portions of operations automated. And in 10.0, we thought to ourselves is, well, if a problem today is solved in 4 hours, can we solve this next time with automation? And can we take it another step forward to say, can we even dare to say that we can prevent the problem or capture the problem before it really impacted your business? And can we need to do that on a hybrid network? So to include your LAN, your WAN, your traditional data centers, your software-defined data centers, and also the cloud. And lastly, can we do this for every problem? Not only the simple things, maybe things that are highly repetitive, such as a link flapping or node down, but more the complex things as well, such as your QoS configuration drifted, and that has caused problems in your voice or your video applications. All of these things we considered as we really went on this bold goal of creating 10.0. So today, we're very excited to introduce the 4 key innovations in 10.0. First is our multi-cloud support. And through this, we're accomplishing what we sought out to do to scale to any network. The second thing is a big innovation of ours is intent-based automation. And there's 3 specific innovations within it that I'd love to introduce to everyone that really takes our proactive automation to the next level and scale to really any problem, including the most complex in your network. Third, we will introduce incident-based automation, collaboration, that will really serve to scale to any person. Because network teams are becoming more and more diverse and fragmented with different technologies and different specialization, how do we bring all that knowledge together when you need it the most? And that's during incident collaboration. And then lastly, we'll close that off with no-code, low-code automation to continue our path to make automation available to any engineer to build. And we're really excited to share this with you. I think we have made a monumental advance in this area in 10.0. So first, let's dive into multi-cloud support. And we start with what we're hearing from the industry and our customers. And what we're seeing is that, and Gartner had this great quote, is that network operations teams today are forced to work differently with clouds. Well, why is that? Well, first of all, application and services are spanning the entire hybrid network with cloud. So with cloud, you're having an additional environment, not instead of oftentimes. So you still have the LAN, the WAN, the data centers, and sometimes the wireless, and then you have SD-WAN now into the cloud. So now your network environment's permutation just increased another fold, another order of magnitude. And this creates a lot of collaboration, end-to-end visibility challenges for anyone that's looking to operate and to be able to troubleshoot applications and the services. And we see it more and more now is that there's a new team that's being created, and that's a cloud team. And this team works in conjunction with the traditional network teams on this particular challenge of being able to deliver applications much more quicker to your users. And with this new environment, there will be new specific cloud data. Now, there's a lot of great tools out there like CloudWatch, Datadog that provides visibility into the cloud. But when you're troubleshooting end-to-end, you will need to have that entire visibility together. And that forces network operations teams today to do things differently and be able to having to collaborate and consume all that data at once to understand the nature of the problem. And lastly, we're hearing this more and more from our customers is that cloud is a black box. It's excellent in creating the orchestration and making everything available when you create the clouds. However, there's a lot of objects and sometimes foreign to network teams that are now being created. And after the fact, now trying to diagnose and troubleshoot often is a much more challenging task. So today, we're really excited to introduce our visual cloud management for AWS and Azure that takes all the benefits of NetBrain that you know and love to the multi-cloud, including auto discovery, end-to-end visibility with our known maps, creating those application dependencies across your entire hybrid network, being able to use our data views to consolidate all the different data, whether it's from Splunk, SolarWinds, PRTG, or it's in the CloudWatch and Datadog all into the single pane of glass. And lastly, is be able to use the runbook automation to help and troubleshoot and reduce MTTI and reduce MTTR. So really kind of to bring this into life, I want to turn it over right now to Rick that will really help bring a demo of our new platform. Rick, on to you.
Thank you, Sung. Okay, great. Yeah, so great introduction. What's interesting, especially for those of you who have been with NetBrain, for quite a while, we've always done a great job with the traditional network devices that have been out there. We also currently, prior to R10, support software-defined stuff. So SD-WAN, we see increasing in lots of places, as well as SDN as traditional data centers transition from the brick and mortar and sort of legacy technologies to the more software-defined stuff. And now finally, people are moving to the cloud. And in R10, we're pleased to announce that we're going to be supporting, or we do support, both AWS and Azure as of this latest release. And right behind it, in our next release, we're going to be supporting Google. So what's interesting is we talk to our customers that are using the clouds. They have sort of three basic types of application flows that they're really interested in, right? They're interested in flows within a particular cloud. So they want to understand, how these application dependencies, as Song was talking about, what components are required as these applications are supported. And as you notice, the components are very different in the cloud. For us old school network guys, we're used to routers and switches and firewalls, right? We know what those look like. We have a whole nother family of components within cloud, all kinds of things that are very different. And these actually look like the actual icons that are used from both Amazon and Azure. So they want to understand how the applications are working within the cloud. They also want to understand, if it's a multi-cloud environment, how applications are working between the clouds, right? So a lot of companies have both Amazon and Azure. They like to understand how those applications are communicating. Are they going over the internet, or are they perhaps doing it through some sort of a colo, like an AT&T NetBond or an Equinix? And then finally, if you have applications in the cloud, ultimately they're either going to be offered up on the internet, or they're going to come back into the building and help your organization, either in the traditional data center or those remote offices. So those are sort of three kinds of data flows. And I'm going to be showing you the visualization of that here in a second. But first, I just want to take a step back and show you another way that we can visualize all the different cloud components that you have. So we have this capability called the network context view. We've had it for quite some time. And now we have it for both the cloud stuff as well as the software-defined stuff. Let's take AWS as an example. What we're finding is that these cloud environments just grow like a weed because they start off in DevOps, and then they work their way to Q&A, and then ultimately they make it to production. So as a result, they have lots and lots of different accounts. So we can provide visibility in one place of all the accounts. Same thing from Azure, we can provide visibility into all the different subscriptions, is what they like to call it. And then within a particular region, like here in the US, you can then go ahead and sort of drill down into this, right? So if you have a number of VPCs, you see we can understand all the components that make up those VPCs. We also start to introduce little thumbnails. So you're starting to get a sense for the topology in the visualization that is available. And in this case, you can do the same thing at the subnet level to see what components are inside that particular subnet. How many EC2 instances, are there any ENIs and things like that? As well as all the other components like the different load balancers and gateways and direct connects that they have. So this is just a great way to, again, visually understand how all of these things are connected and supported by each of the different cloud components. And we got a great quote from a customer. We asked them, how do you maintain your inventory? How do you know how many assets you have inside the cloud at any one time? And they said they basically wait for the monthly bill, right? And then they have some sense for that. So this is, again, particularly for those organizations that have lots of accounts or lots of subscriptions, it really helps you to understand what's going on in your cloud environment. Okay, let me go back to the map. And I mentioned about those three different types of application flows. So let me show you an example of what these things look like. And this is basically based on our past technology that we've had for a long time. And so this is really a wonderful way to look at these things and understand these things. So here's a path that has to do with how some AWS VPCs are peering each other, all right? We can get a quick thumbnail of that, and then we can overlay that to the map. All right, so this is interesting. So what we see here is not only do we have a couple of components that we already knew about on the map that supported this flow, but we have a couple new ones that showed up, right? So again, this is just an example as these clouds, scale up and scale down and change over time, and these things can change hourly. Having that visibility so we know exactly what components are used end to end within Amazon is really significant. Let's take a look at Azure. Let's see what kind of an Azure path we have here. All right, so this is actually going to be going over an MPLS service as well. And let me overlay that on the map. So look at this. Again, same thing. This is an interesting flow, right? It sort of starts in the Azure components that we knew about. went through this MPLS cloud, even did a little bit on-prem, right? And then it kind of came back. And we even, again, have additional components that we perhaps weren't aware of before. All right, great. Let me do one more. I want to show you an example of what it might look like coming back sort of in that traditional data center. There we go. Right here, yep. So this, I'm going to do this path here. So this is, again, connecting payloads from the Amazon cloud services back into the on-prem infrastructure. And let me delete this, right? So you can see here, these applications that are hosted over here are now available, back into the building. And so having all this different path technologies and capabilities to look at those 3 different application flows is great. Finally, what I want to do is I want to actually start clean. I want to basically create sort of a new map where I just look at a specific data flow of interest. So let me go ahead and do that. So imagine this is sort of maybe a troubleshooting scenario. We talked about some of NetBrain's other automation solutions like runbooks and data views. And that's what I'm going to be showing you here, is how we can do a path, do a dynamic path, and then bring some data to help troubleshoot this problem. All right, great. So I have a path of interest here. So I'm going to use this multi-cloud path. So this is troubleshooting an application that is connected between both an Azure cloud and an Amazon cloud component, right? So this is interesting. And here we go. Here's where it starts in the Amazon piece. And then let me see, I think there might be some neighbors here. So let me add a couple of neighbors. That might make it interesting as well. All right, so you see here we have 3 different applications housed in 3 different EC2 instances. They are connected through a VPC router. They ultimately go through a virtual private gateway, right? In this case, to go over, the internet, and then it comes back to Amazon, where it's a VNet that also goes through one of its VPN gateways and its own internal router as well. So let's see. I want to start troubleshooting this problem, so you can take advantage of the data views and runbooks and the network intent that we're going to be showing you a little bit later in the demo to help troubleshoot this. Let me show you how this works from a data view perspective. So what we've done is we've created data views to basically pull data from the various components, either directly from an API or from third-party sources, right? So Song mentioned CloudWatch. CloudWatch is a very common thing that's used in Amazon to give you some sense for the performance of these resources. So we're going to bring some CloudWatch data to the map, see what this looks like. Here we go. So this is interesting. So this is giving you some basic utilization of each of these payloads in terms of CPU, packets in, packets out. That's valuable information, if you want to get a sense for how this thing is working. And then let me go ahead and check out Datadog. Datadog, another interesting tool. And in this case, I believe we have it licensed for one of the instances here. So we'll see what those details look like. Great. Yeah. So right here, you see from a Datadog perspective, you have even a higher fidelity view of the CPU utilization and memory uptime and any errors as well. So things like this, using the single pane of glass capabilities from our data views, also using runbooks, and again, we'll show you a little bit the network intent. We'll have the ability to troubleshoot and get to the root cause of these of potential cloud issues. Another quote I like to talk about is the same customer who mentioned about waiting for the monthly phone bill. We asked them how they troubleshoot their cloud instances, and they said they're pretty complicated. So that what they do is they really open up tickets directly with the vendor. So they're really keen on getting more insight into improving their troubleshooting of their cloud-based applications. All right, thank you. Back to you, Song.
Okay, thank you, Rick. And thank you for the great demo. And hope everyone enjoyed seeing that bringing the AWS and Azure support into life with our visual cloud management. We're really looking forward to our customers being able to take advantage of that and seeing this live in their own entire networks. So with that, I want to dive right into the next topic. It's our next innovation. It's intent-based automation. It's hard to have a favorite out of everything that we do today, but this is my personal favorite, as it really recognizes and represents a big innovation, a big advancement in our ability to basically automate any problem. So with that, let's talk a little bit about intents first and take a step back and go a little bit into the network theory. So everyone here knows that There's the hardware layer, the level layer 1, layer 2 in the OSI model that looks at just fundamentally the bare metal boxes, the switches, routers, and then the copper that connects everything together to be able to create the topology to start to build on what we will develop into as the application layer. And the application is really the final result that our users, customers, and partners are able to experience from a business side. Everyone here knows that in the middle is where all the magic happens. And this is where the network engineers that are on the call today are spending day and night creating the network features that they'll be able to carry the intents of these applications, so to translate between the hardware layer and up to the application layer. So these are the MPBGPs, the QoS, the multicast, the firewall ACLs, the VPNs, the load balancing that looks to satisfy a set of network services from reachability, latency, throughput performance, resiliency. All of this is in support of the applications that our users, customers, and partners are using and knowing to love. And this is what we define as network intents, is the magic in the middle. And what we see from our industry today is that there are a lot of different tools to really help monitor the device level. So looking at CPU, looking at memory, looking at a lot of device level type of monitoring that helps to notify us when there's something that could go awry on the physical layer. There's now, with the advent of application performance management, user experience monitoring, that's now starting to put agents within our networks, within our application, and within our IT ecosystem to be able to start to monitor the end result, which are these applications. But what about the things in the middle? The magic that to us, the network engineers, is our bread and butter. How do we start to validate those important intents on the important devices? And how do we start to monitor these so that we can tell when things are starting to go as a problem? And if we take another level into it, is that for NetBrain, every single one of the devices that you manage carry almost a strand of that intent. It's almost like a DNA. The DNA of the network is intents that you look to accomplish through these configurations. And each device carries a piece of that. So we would together implement QoS, multicast, failover on a device by device level. So from this instance, we see of the 1,000 devices that we can manage today, not as 1,000 devices alone, but 10,000 intents. And these are things like next hop IP, triple authenticated users should be able to do X and not to be able to do Y. MTU, outbound QoS policy for voice traffic, security filters, standby states, HSRP states, WAN interface outputs, and state information like error counts. All of these are the things that we start to accomplish and start to use as leading indicators for performance throughput of our applications. So how do then we as an industry, and this is really what we're looking to solve in 10.0, is how do we validate the most important of these network intents? And we start and want to introduce a concept of adaptive monitor. And we all have playbooks in our networks where if something happens, do Y. And we want to take that concept and automate it in NetBrain 10. So if a network, for example, has changed, we have an adaptive monitor that's able to see when a configuration may have changed and be able to set up a second tier type of an architecture, or it can translate that to even more granularity as to what technology has potentially has changed. In this instance, if we see that the BGP configuration has changed, there's a set of things that a network engineer typically would go in to try to validate. Maybe it's that there's an R1, R2 pair in your WAN links that you want to make sure the ACLs stay symmetric. Without it, the configuration drift could cause potential issues down the line. It could be you're looking at your BGP neighbor count. Did I gain a neighbor? Did I gain a new route? Could this potentially be to impacting my performance or my reachability for a key application? Or it could be a BGP status check. And all of these things are the typical intents and the things that you validate on a day-to-day basis. That's not going to be as trivial on the device level, but also not on the application level. So we're proud to today introduce NetBrain Intent-Based Automation with 3 key innovation areas. The first is a network intent object to help be able to define and automate even the most complex of your intents. The second is adaptive automation. is a set of, and we re-architected our backend to be able to support being able to monitor not only the 10,000 devices, but the 10,000 intents that you define in your network. And lastly, how do we bring all that information to life so that your engineers, when they need it the most, is able to see the result of all these automations running in the background so they can get to the root cause much faster. So again, I will turn to my partner in crime, Rick, to really bring a lot of this to life with a quick demo. Rick.
Great. So yeah, so this is this is interesting. You know, every organization does have sort of best practice troubleshooting, whether it's in their head, on the whiteboard. Some folks codified in a spreadsheet. You know, some people actually print books. What we're claiming is that you can take those playbooks, take those best practices for common troubleshooting methods and means, and automate them, which is fantastic. So what I'm showing here, this is in fact a decision tree, and it's sort of a three-step process is the way this works. You know, we have probes that are looking proactively for various changes that happen in your network. If any of those probes are triggered, then it does a further level of troubleshooting, just as Song explained, looking at ACLs, looking at the size of the route table, maybe running some CLI commands, and then ultimately coming up with a diagnosis as to what the problem is. And so what's interesting is these triggers can be triggered either by third-party tools like ServiceNow and Splunk, or they could be using our adaptive automation. These can be things that we have, where NetBrain is now on watch, and this is all happening in the background without any human intervention, completely automated, looking for these problems, which again is hopefully part of that proactive solution. And as you see here, I'm going to walk through a couple of examples. This first one is an example of BGP. BGP is a very complicated protocol, and we see here that there's been some changes to this BGP process, right? And then there's two legs to this particular adaptive automation. One is, let's see if the ACL is still symmetric, and then also has the BGP table changed. And actually, as you see here, it's highlighted in red. It means this, in fact, that this trigger was in fact, you know, a result of a probe detecting a problem, right? So that's why it's highlighted like that. So let's dig into these things. So we see here that, yep, I'm definitely getting some sense that something has changed with those BGP echoes. Let me open up the network intent. And I can see here that between these two routers, US boss R1 and US boss R2, that the table is now in fact not symmetric. So that's a problem, right? You know, that's a problem which could result in, you know, your routing, you know, not being completely stable. And this is a very common example. We call this config drift. Perhaps somebody did an update and they cut and paste a previous example, and as a result, these things are now no longer symmetric. So knowing that we have the root cause, this is something that we can go ahead and in this case, it looks like it changed here, and they can go ahead and remediate the problem, which is great. Let's look at the other leg, right? So this was talking about, did the actual BGP table change? Take a peek at that. Right, so in this case, this is specific to a specific route. And, you know, particularly in large enterprises, these route tables are big. And having to kind of comb through and do that needle in the haystack to see what routes have changed and what exactly were the details of that change can be a very time-consuming thing, almost very manual. We do it right here, where we can pick up, hey, what exactly changed? You know, was it something to do with the weight? Was it something to do with another routing metric, or was it the path? So having this, you know, sort of very deep diagnosis happening automatically, right, and then presented, you know, for humans to digest is fantastic. So this is an interesting one. This is another sort of trigger that talks about BGP route changes, and it does three things. The last thing is actually checking the path, and in this case, this was a positive result. So in this case, the actual path, the AS path, has not changed. Peek at that real quick. Yep. So this is a good finding, right? So again, this is an example of proactive automation working in that there isn't a problem. That's great, but now I can focus on some other things, right? And I really like the way that this sort of process, this sort of visual flow of how these troubleshooting methods and means happen. This makes sense to me, and it's very easy for you in your organization to take your playbooks and automate them using our automated automation here. So let me also do one last thing I want to show. And this is quality of service. QoS is another, you know, can be a tricky thing, particularly if you've had any policies downstream that don't quite match the end-to-end policy. So you can see here, this is what has happened, and we dig in. And yep, it looks like the first device is good, but a couple of the downstream devices, their QoS policy is not quite matching. So again, this could lead to potential issues if you start to have too much traffic and it's dropping the wrong traffic at the wrong time. Okay, great. So hopefully this, this helps from a quick demo perspective, give you an overview as to how this adaptive automation works, how we can define these triggers based on your best practices and troubleshooting playbooks, and then ask some really detailed questions and get to the root cause of these issues very, very quickly. Again, with no human in the loop when we have it triggered for NetBrain probes. All right, thank you very much. Back to you, Song.
Great, thank you, Rick. Yeah, it's fascinating. All of those things are happening in the back end to start to validate before the engineer even gets there. So this really continues our mission to be able to give the user much more information before they even reach the ticket. And a lot more of that diagnosis can happen before that. So that's excellent. Thank you so much, Rick. Great, so moving right along into our third key innovation is our incident-based collaboration. And this begins to talk about our third tenet of our vision, which is to scale to any person, the automation and the information that we provide. So starting with what we're hearing from the industry and the customers is that siloed network operations groups are more or less the norm now, limiting kind of a lot of the cross-functional alignment. And we're seeing that a lot of these new teams are being generated, whether it's for new technology or it's a new environment, or just collaboration with the existing IT groups of security and application. Collaboration inefficiencies are slowing down the problem resolution. The more interfaces between the team's handoffs, the more potential for friction and a reduction in efficiency. And a lot of the incident trackers today lack the network-specific information, such as topology, detailed diagnostics, to be able to transfer from one team to the next. And I remember one customer kind of mentioning this, is that they feel that whenever they get on they need to transfer information, it's either down on paper in a document or on a call. And be able to see that visually will help them tremendously. And difficulty in documenting the findings, especially during escalation. What a tier 1 engineer may have done for tier 2 and tier 3, we're seeing that a lot of network teams in tier 2 and tier 3 are repeating a lot of the things that they've already done in tier 1. How do we then make use of the information that's already there at the time of the event so I can really accelerate and shortcut the problem solving and the troubleshooting process for tier 2 and tier 3? And lastly is this additional expertise from other teams and that are oftentimes necessary now to troubleshoot some of the more complex tasks. How do we then bring that technology, that expertise and that knowledge into the team during collaboration is continuing to be a challenge. So today we're really excited to announce our incident-based collaboration. And the concept really starts from, for every ticket, whether it's a change, it's troubleshooting, or any task in your network, creates an incident within NetBrain. And this incident has 3 facets that really support it. The first is the incident pane. And this is an augmentation of what you're already familiar with in NetBrain today, except with data, with also a messaging capability to collaborate from multiple teams together to be able to get to the root cause. Second is the incident portal. And this is really created for those the teams, the non-network teams, that will really benefit from having visibility into the incident, whether it's from security, application, but even your customers and your users, giving them the visibility that what's going on in the network and the troubleshooting process can bring about a lot of transparency. And then lastly is Smart CLI, and not least is Smart CLI. A lot of times we still need to dive into CLI to troubleshoot those most difficult issues, and be able to publish those findings and that data directly to the incident pane and incident portal is exactly what we're looking to do. So between these 3 things, we're looking to share the map, synchronize messages, and also synchronize the data, share the data between the 3. So without further ado, I'm going to turn it back to Rick to really kind of showcase this in a demo. Rick.
All right, great. So if you are aware that there is some incidents that are ongoing and they are if NetBrain is being used as part of the collaboration method, you can go right here and track these various issues and just go ahead and join one of these troubleshooting events right here. Let me go ahead and join this one here. Great. Look at that. Everything's broken. That's bad. So let me go ahead and join this group. And you can see that now I'll be working with Song to help to troubleshoot this problem. So I see that there's a map. This is a lot of different devices here. So you know, my spidey sense says, why don't I go ahead and just bring up a runbook and do some overall health monitoring just to get some sense for just overall health of the network. All right, I'm going to do this at a more higher rate. I'll go every 15 seconds. And I'm happy with these KPIs, just overall utilization of interfaces, CPU, and memory. This should be pretty good. So let me go ahead and run this. And so what this is, you know, as I start to troubleshoot and as the data starts to show in the map, what I can then do is once that data is on the map, on the dynamic map with that single pane of glass, I can share that back to the broader team here, right? So I can see as I zoom in, it looks like these devices we're getting statistics here. Things are green, right? So that's good. Yeah, and it doesn't looks like from an overall health perspective, we're in pretty good shape. So what I'm going to do is I'm going to share that to the broader team. Do that right here. And I can even add a little note. Good. And then as other people join the troubleshooting process, as they find data and they want to share data, they can do that right here inside of this message pane. So again, this is just wonderful to have all this visualization. You know, typically you're on a phone bridge with, you know, dozens of people and you're just talking, you know, or maybe you have a Slack channel or a Teams channel, but it's just a lot of text flying around and maybe you're doing screen grabs. This is real live dynamic data, you know, in the map that I can actually take advantage of, do some sense making. Right, so let me go ahead. Looks like Song did troubleshooting as well. So he executed some CLI commands. So that's good. So he went ahead and ran some CLI commands as well, maybe trying to get to the root cause. And these are things that I could then go ahead and also sort of validate and verify. He saved a step, right? If this was probably the next thing I was going to do, now this has been done. If this is great. This is great. And as we continue to troubleshoot this problem, at some point you probably want to bring in other people to help either verify that you got to the root cause, you know, kind of get to what I call that mean time to innocence, or perhaps you need help from a security engineer or somebody from the server team or the cloud team. And the way you can do that is if they're not normal NetBrain users, we have this incident portal that Tom talked about. And it's very easy to kind of set this up and make it available for these other folks. And basically this just becomes a well-known URL that you can hit, right? And then what's interesting is some of the data that we've already gathered, all the data we've gathered to date is right here inside that message pane. Here's the map, right? And it looks like there's even a note now here, which is great. So now we're seeing that in this case, you know, this interface is clean. So that's one less thing to worry about. So again, having this visualization too is just fantastic. A lot of times when you collaborate, you know, across the organization, you know, you almost talk in different languages and they have different tools and systems they use. But this is very intuitive, right? It looks like a Visio. We have sort of this this thing happening here on the right-hand side that makes sense. It's informing everybody what's going on. So the portal is really just a great way to bring in those other teams and get their consensus and help get the root cause. Okay, great. So then the last thing I want to show here is the ability to also kind of go old school if you need to and use Smart CLI. Again, at some point, you know, so we're running some of the automation here. We ran some runbooks. We ran the overall health monitor. Things look pretty good. Maybe what I want to do is I want to dig into this router. I know this is a core router in my environment, and I want to see if I can maybe get more detailed information directly. So the beauty of NetBrain Smart CLI, and we've had this in the product now for quite some time, you know, the beauty of this is that, you know, it allows you to do a couple of things that you can't do with just a normal console hopping session, right? So let me just go ahead and connect right here. So for instance, history, you know, as you go ahead and execute these CLI commands, it stores all these things. You can create a baseline, right? And then based on that baseline, you know, diff on that and see if anything has changed. And as you go about, you know, running these CLI commands, you can even share them back into that incident. And you can also create sort of a monitoring automation on the fly. So a lot more capability than just a standard, you know, logging in through an SSH process. So here I see I'm looking at the overall route table. Maybe if there's something of interest here that I want to share back to the incident pane, I can do that. I just select some of the output here. and I can publish this back to the team, right? Say, check this out. And I can also even add it in the map note, and I can even create runbook nodes. So this is another great benefit. If you just use NetBrain during your CLI sessions and you sort of find out a great troubleshooting mechanism, you can codify that into a runbook. And now that is something that could be used and reused by the team. It's just a great way, for having this automated and adaptive automation, grow over time. And a couple of things you can do here, like I mentioned, if you want to go ahead and select the baseline, you can do that. So I was maybe compare yesterday's CLI command to this one here and see if there's any diffs. And no, it looks like this is pretty clean. So it's not a routing problem. And then quite often too, if you think it's a state change situation and you want to run the same CLI command over and over again, you can do that as well. And just create a little, have this run on a regular basis, right? And have that information come back and inform the incident pane, which is great. All right, great. Let me go ahead back to the incident pane here. I want to see if that note has showed up. Go back to the incident. All right, very cool. All right, so hopefully this gives you a good explanation of how you can go ahead and use the incident pane, the incident portal, and some of these other methods and means to go ahead and troubleshoot something quickly as a team and have all this information at your fingertips in a very visually sort of intuitive way. All right, thank you. Back to you, Song.
Excellent. Thank you, Rick. It was a pleasure collaborating with you on troubleshooting that particular incident. And I hear this most too is troubleshooting can be a lot quicker and easier if we have the benefit of having baseline history information. And having that in your fingertips in the CLI will be very beneficial for our customers. That's great. So last but not least, we're going to dive into the no-code and low-code automation. And we're really excited to introduce two key concepts, the visual parser and the feature intent template. And looking into what we see also from our customers and industry is that the industry is moving towards really leveraging low-code automation to democratize network management, especially network automation. And the reason for that is we see it a lot of times now today as well is that traditional methodologies, network engineers may not have the necessary coding skills. And what that translates into oftentimes is that the NetOps and the DevOps collaboration is required to start to automate, and that's time consuming. And a lot of times the requirement creation, translation, code creation, and test can take up a lot of time. And the number of network tasks nowadays needing automation is huge. So how do we then be able to scale this partnership and be able to get to the level where we're able to cover the extent of the network tasks that you have today? And to add layer into that is because of our networks are becoming much more multi-vendor and it's spanning across different environments, building automation that works on all of that is becoming increasingly difficult. And I've talked with one customer that mentioned to me that a lot of times building the initial automation is no longer the most time-consuming part. It's actually maintaining it afterwards and being able to adapt it to all the changes that will come afterwards. So today, we will introduce two key innovations. One is our visual parser. And our goal is to be able to introduce to the knowledge holders of the network teams, the engineers that are actually designing and troubleshooting and solving these issues, for them to be able to very quickly and easily build automation through a no-code fashion. So we can take that translation process of knowledge to automation down to minutes to hours, instead of today, maybe there's hours to days and maybe even 2 weeks. And lastly is introducing the feature intent template to provide a low-code template-driven automation for the automation for automations. And through this process, we're building the foundation for all of our automation, is taking the key infrastructure intents from device configuration CLI and bring that in to be used by the network intents, executable runbooks, and our data views that you know and love within NetBrain. So with that, I'll turn it over to Rick the final time to show this live within the demo environment.
So yeah, so in order to show this visual parser, I'm going to do it in the context of troubleshooting some interface issues, and I want to try and understand a couple of KPIs specific that I'm interested in. So I'm going to go ahead and just create a quick notebook here. I'm just going to run that show interface command across all these devices. And as I'm sure everyone knows, depending on how many physical interfaces you have, as you run the show interface command, it can be quite verbose. There can be a lot of information here. And usually when you're troubleshooting, you're really only interested in one or two key elements of that, right? So this is where we're going to go ahead and create a visual parser, right? So let's say what I'm interested in is the interface up, is the line protocol state up or down, and what's the MTU, right? So there's 3 questions I'm going to ask. So I go ahead and very easily create a new parser here. And what's great, you can even be even more specific if you want to create specific parsers for specific devices. I'm not going to worry about that right now. You can also do it based on the config or the CLI command. Right? This is live troubleshooting, so I'm going to do the CLI command. And I am going to do a show interface. Go ahead and pull that. So let's say I'm still interested in that main core router there, that R1 router. Let me see if I can pull that up. And I'll use that as a test case. There we go. And so now what NetBrain's going to do is it's going to execute that CLI command, pull the results in, show it right inside the visual parser. Okay, great. So again, lots of information that flies by for each of these interfaces, but I'm really only interested, in a couple of things here, right? So what I could do is I can say, you know what, why don't I go ahead and do a simple paragraph parser here. And what I'm going to do is I know that I'm interested in the state of the interface, in the state of the line protocol. So I can just enter this in very easily, defining interface as a variable, right? And say, what is the state? Is it up or down? And you see, as I type these things in, it is already showing you visually, how I am going ahead and parsing this and what that result looks like, which is really kind of cool. And then I'm also going to add in line protocol. And what is its state? Great. So now I have the ability to say, the classic up in the world for our Cisco buddies. What's the state of the physical interface? What's the state of the line protocol? They're both up. That's great. And maybe I have one more KPI that I'm interested in. And again, maybe my spidey sense tells me there may be an MTU issue here. I can define that as well as a variable down below. And great. So within seconds, I have a parser that's parsing out 3 specific pieces of information for each of these interfaces, right? And that's great. And what I want to do is I want to make the interfaces sort of the key so that everything is associated with a specific interface, right? These 3 different things. And then what I can do is I can save this so I can reuse this in the future. I'll call it check. Great. So there we go. So I go ahead. I've successfully built my first parser, and then I can go ahead and take advantage of it to inform other pieces of automation that we have here at NetBrain. So let me go back to the map. I'm going to run that CLI command again, and we'll show you how that parser result looks. All right, great. So let me go ahead. I'm going to go back and I'm going to rerun that parser command. There we go. So actually, first I'm going to rerun the execute CLI command. Run again, and then I'll see if the parser is available. All right, great. So if I go down here, where before I had no parsers available, there's the one I just created, that MTU check. And you can see it sort of highlights, what pieces of information am I looking at? Is it the physical interface, the line protocol, the MTU? And then I can further, there's a bunch of easy buttons right here. If I want to go ahead, I can add this to a data view. And that's something that can be brought to the screen. I can also create alerts, right? So I can go ahead and create an alert, and maybe in this case, it's the, MTU mismatch. It's a basic alert. And I'm basically saying, let's assume 1500 is my standard MTU size. And if it doesn't match 1500, then I want to know about it. to the screen, and here we go. Right, so very easily I'm able to create a parser on the fly, looking at specific KPIs. I can then add that to a data view that could then be lit up on the screen as a single pane of glass. And I can also have an alert if I would want to schedule this data view to run on a regular basis, and I can be notified if any of these things change. So again, really easy. All you really need is a sense of, you don't need to be a programmer to take advantage of these things. You just need to understand the network technology and how to run either CLI commands or decode a config file. And you could use this visual parser and create these parsers really quickly. All right, great. Thank you. Back to you, Sam.
Great. Thank you, Rick. That was very powerful and very exciting. The visual parser hopefully can reduce the barrier of a lot of us engineers, network engineers, creating some of the parsers. That's a building block for a lot of our automation. Excellent. So today we only had to have an opportunity and time to really talk through the four major innovations, but there are hundreds of other improvements within NetBrain 10. From Splunk integrations, improved runbooks, improved data views, security enhancements. We talked with a lot of our customers and enhancing the administrative side of things, performance enhancements, and just much, much more. So we really look forward to everyone being able to learn more about this monumental release for us and be able to take advantage of all the new features and functionalities. So bring this back full circle. What is our fourth generation technology? And we're there to really try to tackle the proactive automation problem. How do we capture problems before they fundamentally impact your business across the multi-cloud, full fiber network? And we have to do this also by reinventing ourselves and moving to an even more adaptive and distributed and scalable architecture so that we can monitor those, not those 1,000 devices, but the 10,000 intents that operate within your network. So with this, we conclude today's webinar, but this is only the beginning of the journey. So if you're an existing customer, please request an upgrade. It's live today. We have a dedicated landing page for you to be able to interact with us and learn more. There will be a lot more information, including release notes, this particular webinar, and also the What's New document that'll be made available today as well. If you're a prospect and you're just wanting to learn a little bit more about NetBrain, please feel free to request a demo, and one of our team members will be happy to set up a meeting with you to set up a customized demo for you and your environment. So great. Thank you so much for coming today and listening and joining us in this monumental release. And we look forward to hearing from you.